Yes, I'm back.
Yes, dear. So in the previous class, हमने क्या start किया था? So I think we are done with this chapter, right? So only the one topic was left, which is series combination and parallel combination disadvantage and advantage, right?
Yes,
So we
sir.
have done that thing. Okay,
We finished the chapter and we have to
Mhm.
start magnetic effect of current.
Very good. So let's start the chapter. So that's all for this
Sir,
chapter. So,
sir,
yes,
I
Zainab, dear.
told you about the cancel topics, right?
Not like you have just told me that electric generator is not there. So tell me which topics are not there in the syllabus?
Sir, 1 minute. Sir, electric motor is not there.
Hmm.
And magnetic induction.
Hmm. Okay. So basically, induction and the electric generator motor is not there. So I think till
Electric,
Fleming's left hand rule, right?
yes, sir. Electric generator is not there. Domestic electric circuit is there, and
Circuit.
one paragraph above it, the AC and DC is there.
So what paragraph about?
Yes, sir. It's about the DC
Difference between them,
generator.
AC and DC?
Yes, I guess so. Yeah.
Actually, it's a very small topic, not a very big deal. 5 minutes or 10 minutes topic because AC में अभी इतना आप कुछ डिटेल में पढ़ेंगे नहीं. Will not be like basically going into the detail of AC. In the 12th class, when you will take science stream, there's a chapter in physics, alternating current, basically totally based on AC. The kind of electricity do we have in our in the households is AC, alternating circuit, current, sorry, alternating current. Clear?
Yes, sir.
Yeah. So direct current, like basically the battery. So these are the direct current problem things. So just give me a second.
Yes, sir.
So we have to understand basically you can say the magnetic effects of current. Okay.
Sir, Jan 2nd is my science exam.
Jan second
Yes, sir.
is your
Jan 3rd.
Jan of third. So yes, so till then we'll be able to cover the chapter easily because it's not as like if the chapter is not omitted, like the parts which are there is not omitted, then it will be a big chapter, like the electricity and light. But now, right now, it's a very small chapter after omitting major topics. Basically, the starting topics are very introductory part, and you have seen this thing in the real life as well. So it's not a big deal to understand those topics. Only the part which is cancelled or omitted has a very, you can say, complex concept.
Yes, sir.
Yeah. Okay. So basically, let's understand what is the meaning. So basically, we will be doing the study of the magnetism. So basically, Zainab, so right now, magnetic effects of currents means, so you have seen, so let's do the first basic thing. So first basic thing is that in your life is that you have seen one thing around that, suppose that there is a big tower. You have seen big towers of electric wires are going through that tower just to supply the transmission lines from one city to another city. I've seen this in my villages as well, so I think you have also seen these things. So
Yes,
like
sir.
these kinds of towers, just suppose these kinds of towers are there. These kinds of tower transmissions line are going from one city to another city. Yes or no?
Yes, sir. I've seen it.
Yeah. So these are the big towers basically. So high frequency of current is basically high voltage of current is passing through these wires. So you have seen this thing. Just see this thing. So this is our tower, and around this tower, a kind of region is restricted to everybody, because when the current is flowing through the wire of this tower, a kind of field is generated which attracts something towards it. So that field, because the current is there, so that current will introduce some magnetic field. Magnetic means it will attract It will magnet. What does a magnet do? It attracts,
It attracts like
obviously.
metal and all.
Yes. Okay. So basically, that's why when there is a current flowing into this in any circuit, like a magnetic field will be generated. It depends how much magnetic field will be generated. It depends upon the magnitude of the current. If current is very high, high magnetic field will be generated. If the current is very low, so low, weak magnetic field will be generated. Clear?
Yes, sir.
Clear? Yes or no, dear?
Yes, sir, it is
Very
clear.
good. So basically, so now we will be dealing with the properties of magnetic field and what is basically magnetic field is there. Okay. So let me write down the things. So Zainab, one more thing, dear. So I think you must have received the handwritten notes of physics from the management.
Yes, sir, I received
Yeah.
it.
So in the next class, dear, just go through those notes and read out and understand a little bit about the current flowing through the conductors. We will be doing the what will be the type of shape of a magnetic field through the various conductors. Clear?
Yes, sir.
Like straight wire, circular plate, and all the things. So in the next class, try to read those things before coming to the class. It will be easier to understand and will be like it will be a little bit you can say it will take less time to basically explain that topic. So we can have you can say light and human light. We can have a different you can say thorough overview, not a very deep overview, just a brief about it so that we can cover all the chapters in one go. Okay.
Yes, sir.
Okay. So yeah. So basically, let me write the things first. So basically, what is magnetic field? Magnetic effect of current. So the term the magnetic effect of current means an electric current flowing current flowing a wire produces magnetic field around it. Around it. Okay, Zainab.
Yes,
When
sir.
a current carrying conductor is basically like a current electric current is flowing through a conductor, so it means that it will produce a magnetic field around it. It depends what will be the strength of the magnetic field. It depends on the current. What is the magnitude of the current flowing? Clear?
Yes,
Clear,
sir.
Zainab? So basically,
Yes, sir.
let's do a basic, you can say, analysis of a magnet. Basically, a magnet is a kind of like this, in which North Pole is there, okay, and South Pole is there, okay. So basically, the basic property of a magnet is like it will attract the opposite side and will repel the same side, same pole. Yes or no?
Sorry, sir, I didn't get you.
I'm saying that North Pole will attract the South Pole, not the North Pole. It will repel the North Pole. If the same poles are there, so it will repel, just like the electric charges.
Yes, sir.
Yes or no?
It will repel. Same
Repel.
side.
Okay. So basically, if I basically divide this, you can say bar magnet into two equal parts. So how, like, will there be any other pole? Like, if you basically, so will there be only south pole in that magnet, in that part of magnet? Suppose that this half, like basically this complete magnet is completely divided into two equal parts. So what will happen after when you basically break this into two parts? Here North Pole will be generated and here South Pole will be generated. So every
Yes.
magnet has two poles. If you break that magnet into two parts, a new South Pole and new North Pole will be generated to balance out the poles. Clear?
Yes, sir.
Okay. So these are the you can say the basics of the magnet. Okay. So first of all, let me write down the thing, which is what is basically magnetic field. So so basically, when the current flows through any conductor, it will behave like a magnet. It will attract the bodies. Okay, clear?
Okay.
That's why. Okay, that's why it's attracting. Na? If it's behaving like a magnet, that's why it is attracting the other things.
Yes, sir.
Yeah, the space around surrounding magnet if force is exerted is called a magnetic field. Clear?
Yes, sir.
Okay. Okay. So let's understand one more thing is magnetic field line. So basically, we will understand what is the direction of the magnetic field. So we'll be understanding the magnetic field direction by the magnetic field lines. Clear? We'll be denoting the magnetic field in which direction it is basically going by a magnetic field lines. Clear?
Yes, sir.
Ah. So basically, suppose this thing, this is again north, this is north pole and this is south pole. Clear? So this is so basically the magnetic fields travels from just like the electric charges, like electric current, not electric charges. So it travels from north to south. So like this. Okay. You can see this thing. It is going from north to south. And here it's a little bit circular right now.
Yes,
Clear?
sir.
Yeah. So is it clear to you?
Yes, sir.
Any doubt?
No, sir.
Sure.
Yes.
Okay. So here this is called these are the magnetic field lines. Clear?
Yes, sir.
Okay. Okay. So magnetic field line, let me write down. Okay. So these are the magnetic field lines. Basically, the magnetic field lines are also the imaginary lines. These are imaginary lines. Basically, we just assume this thing, but it is proved practically that these lines present. Okay. So that's how do we know the shape of these lines? By performing the experiments. Clear?
Yes, sir.
The imaginary line representing the magnetic field is called a
So, like, how do that imaginary lines form? Like, just like that they form, or by certain metals they get formed?
basically that depends on the shape of the conductor. It depends on the shape of the conductor, which shape of the conductor we are basically taking. If the conductor is a straight line, so circular magnetic field will be there. If the conductor is of solenoid, so this kind of magnetic field will be generated. If this metal is of a basically rectangular plate, so circular magnetic field lines will be there, and in the middle, so like not concentric circles will be there. Clear? So it depends on the materials. So I will be not materials, on the shape of the conductor. So we'll be doing that thing in the detail itself. Don't worry. Okay.
Sir.
Let's
Yes,
right now we are just doing the basic properties of the magnetic field lines. Clear?
yes,
And
sir.
magnetic. Okay. So let me write down the lines first. So magnetic field lines originate from south, North Pole, originate from the North Pole, North Pole to the of a magnet, and end at its South Pole. That's what I've explained to you right now. I hope it's clear, Zainab.
Yes, sir, it is clear.
Second is, suppose this is first line. Let me write properly. Second is magnetic field lines are closer to one another and near the poles.
Sir, if they come closer, they are likely to intersect, right?
No, they will not intersect at all. The major property of a magnetic field line and electric field line is that they don't intersect.
They are parallel.
No, they are not parallel. They will not intersect at all. They will be closely, you can say closely bound, like very
Crowded.
closely packed, but they will not intersect at all. No, if
Like
they
they
will
will be
intersect,
crowded.
if they will intersect, you will get two directions of magnetic field, which is not possible. Okay?
Yes, sir.
No two magnetic or no two electric field lines can intersect. I will
Like
write down this thing as well. Don't worry.
they
Near
will
the
be
pole.
crowded at a point, but they never
They will
intersect.
be
Crowded at a point, but
crowded
they
at a point, but they will not intersect. Yes, that's the one of the major property of the magnetic field line and electric field line as well. These two properties are common in both.
yes, sir.
Near the poles of a magnet, but they are widely separated at other place. You can see this thing in near pole. You can see this thing, they are very crowded. But at the when they go from, they basically though they go far from away. So basically they are less crowded. Clear?
Yes, sir.
Next is the magnetic field lines do not intersect. One another. Okay, so basically why they cannot uh intersect is that, so you have heard the word tangent. Tangent.
Yes, sir.
Okay, tangent basically in like basically tangent will give you the direction of the magnetic field line. Okay, suppose that I'm putting one tangent here. Suppose that one tangent I have produced one tangent. So if they will intersect, suppose a kind of magnetic field line is intersecting. At same point, it's also giving me at the same point. This is intersection, I'm also putting the one more tangent. So is it possible at a single time you can get two directions
No,
by a
sir.
same magnetic field?
No.
Obviously not. If I'm saying that, suppose you have asked from one person that how you will go from suppose that Delhi to Mumbai. If same person is pointing out like this, Mumbai is also in this direction and Mumbai is also in this direction. Is it possible? Two
No,
directions?
sir.
It's not possible, obviously. So that's why these two lines, the magnetic field lines cannot intersect at all. Clear?
Yes, sir.
I hope it's clear, dear.
Yes, sir. It's very clear.
Very clear, very good.
Yes.
So yeah. Obviously, it's not possible to have two like particular direction. If a person is basically, you can say, like telling you in this direction, you have to go to the basically to reach at your destination, and same person is saying that you can also use this direction, but it's not possible. This direction is going in another direction in another way in to another city, and this one as well. Okay, that's what is clear.
Yes.
Let me write. Hmm. So these are the basic properties of the magnetic field lines. Clear? I hope it's clear to you, dear.
Yes, sir. It is clear.
Sure?
Yes, sir.
Any doubt?
No, sir.
Okay, just give me a second. Let me take some questions first.
Sir, the doubt I have is that uh,
Yes, dear, go ahead.
that means, like you said, the magnetic field means that the electric current flowing in a wire. That wire should, like, I didn't exactly get it.
So basically what happens, the magnetic field means magnetic field will be generated. Suppose right now we are basically learning the magnetic fields by current. Okay.
Yes,
So basically if the current is flowing through any conductor, a magnetic field will be generated around it. Okay.
yes,
It
sir.
will behave like a magnet. If it behave like a magnet, so there will be magnetic field as well. Clear?
Sir.
So magnetic field and electric field are interconnected. Electric current is interconnected to each other. When you will go in 12th class, there is a chapter in which you will study the current, the current is flowing through the conductor, and you will have to find the magnetic fields as well.
Yes, sir.
Yeah. So right now, this is the starting. This is the brief of this chapter. The starting. So basically, when a current is flowing through a conductor, so a magnetic field is generated along with the electric field. So that magnetic field basically attracts body. Clear?
Yes, sir.
Is this clear, dear?
Yes, sir. Now I got it.
And the basically a magnetic field can be generated by normal magnet as well. I'm not saying that it cannot be generated. So basically, right now I've just told you like whether it's the magnetic field generated by electricity or a normal magnet, the properties will be same because it's a magnet ultimately.
The
Clear?
doubt I had is that only by a conducting wire only magnetic field will be formed.
Yes, yes, dear. If
Only by
obviously,
that.
obviously, देखो, what happens is that if current is flowing, current in which material your current can flow, only the conductors.
Yes, sir.
And if the current can be flowed, it means that it will generate some magnetic field along with the electric field.
Yes, sir.
So that's why only conductors can be behave as a magnets.
Yes, sir.
Okay, is this clear now?
Yes, sir.
Okay. Okay, so just a second, let me. And one more thing is that I just forgot to mention here. Magnetic field intensity will be very high if they are very closely packed, crowded. The magnitude of the magnetic field will be very high if the magnetic field lines are very closely bounded together. Clear?
Yes, sir.
Suppose just like a normal, you can say normal concept, just like say that atoms are very closely packed in the solids, loosely packed in the liquids, and very loosely packed in the gas. So as you can see this thing, it's very difficult to basically break a solid because the density is very high. So same thing happens. So magnitude of magnetic field will be very high. Basically the you can say the magnetic field lines are very closely crowded. Clear?
Yes, sir.
I hope it's clear to you, dear. Any doubt?
No, sir.
Magnitude of magnetic field will be very high if magnetic field lines are closely closely crowded, you can say. I hope it's clear, dear.
Yes, sir, it is clear.
Sure.
Yes, sir.
And basically, this magnetism, this basically when the magnet is generated because of the current, that magnetism is called as electromagnetism. Okay. One more thing, somebody can
Yes.
ask, like it can be a one marker, an MCQ. You can say name the magnetic effect of current, like somewhat like just let me have a question. So you can say like suppose this can be asked like in such a manner that electromagnetism is the magnetic field generated by electricity by normal bar magnet, and somewhat like these kinds of options will be okay. Clear, Zainab?
Yes, sir.
Okay. The magnetic. So you have seen one thing here in have you have you noticed that uh, electric bell, doorbell? So it's connected. It's a kind of button there in your bell, like in the like you just basically push it and it will ring. So what happen is that it's a kind of electromagnetism. When you push that button, a current will flow and the metal inside it will behave like a magnet. And that's why once you press the button, it will ring. But when you lose it, when you leave it, basically the bell stops. Yes or no? So that's the reason. And the magnitude is very high in the electromagnetism. The magnitude of magnetic field is very high. Clear?
Yes, sir.
The magnetism electric current is called electromagnetism. So this can be a one marker in your school or in boards as well. Like not your school, in boards as well.
Sir, electromagnets are permanent magnets, right?
No, electromagnets are not permanent magnets. They are temporary magnets. Unless and until the current is flowing through the conductor, it will behave like the magnets. But once the current is it stops flowing, so it will be a normal metal.
Yes.
Yeah. Permanent magnet are like you can see like normal magnets. You have bar magnet, horseshoe magnet, a kind of this U-shaped magnet hoti hai na? So this is called as horseshoe magnet. So this is the permanent. These are the examples of permanent magnets. Clear, Zainab?
Yes, sir.
Yeah. It can be formed, a metal can be formed as a permanent magnet because when like continuous amount of current is flowing for a long time, it will become a permanent magnet. So that's why you will study these things in detail in 12th class. A magnetics chapter, complete magnetics chapter is there. So you like you will be dealing with those concepts and how you will form basically a temporary magnet to permanent magnet, which material is used, paramagnetism, ferromagnetism, or a normal insulator, and these things. So you will understand this thing. Right now, only the brief is there, not a very big chapter, only brief chapter is there, only the magnetic field property, what is magnetic field, how it is generated, what will be the like kind of like shape of magnetic field lines through various conductors. So you'll be taking science in the 11th class, or you will be taking another streams?
Science of
Science. What's your dream? What's your goal?
either MBBS or anesthesia or BNYS.
Okay, basically you will be opting the medical line, right?
Yes, so medical.
Okay. Okay, no issues. So basically these are the things, and magnetics is used in medical as well. You have seen, like, I don't know the proper application, but I have seen some of the applications. You have seen MRI. Have you heard the word MRI? Magnetic resonance image. Magnetism is used in
Yes,
those in those machines. So
yes, sir.
magnetics is already there. So electricity, magnetics, and optics. Optics is used when you basically optometrics, when you study the lens, the eye functioning. So that's how the physics is like everybody says why there is physics in MBBS. So if you don't understand the basic concepts, how you will basically like give the treatment. Some students say
Yes,
that why there is physics in the MBBS where there is no scope of the physics in the MBBS, but there is. Nobody knows that thing. If you don't know the basic concepts, how you will operate the machines. Okay, so that's
yes,
why
sir.
physics is very necessary in the medical as well. And if you
Yes,
don't know the chemistry, how you will give you the like identify the dosage of the medicines, which what is the amount of medicine should a patient should have at at different in different situations. And biology, you already know that biology is used by like veins and all the things. Like I'm very afraid of blood, so I have a blood phobia. So that's why I don't discuss the biology much. So
yes,
that's why
sir.
I've not opted the biology in my 11th class. I had the option, but I didn't. I opted maths. So that's all. Like this is the basics of this chapter. Is it like this topic? Is it clear to you, dear?
Yes, sir, it is clear.
Sure.
Yes, sir.
Okay. Let me give you one question.
Sir, this chapter has any numericals?
No, no numericals. Only conceptual questions. Why the electric field line, like magnetic field lines, do not intersect? Because magnetic field line do not intersect because the tangent to any magnetic field line will give you the direction. If they intersect, two tangents will be there pointing out different direction at a single point. So that's why it's not possible. The first basic question, which can be there, two markers. Tell me the right answer.
The answer is C. Do not
The answer is
cross
C.
one
Very good.
another.
Very good. So let me look some other questions as well. And one more thing, have you seen X-ray machine?
Yes, sir.
The X-ray machine is operated on different wavelengths. Basically,
Yes,
X-ray has a different wavelength. So basically, that you will understand these things when you will study physics. That's why it's very necessary to study physics in the like your finals and pre-finals years, like the 11th and 12th. So everything has a very, you can say, has their own, you can say, like value. Okay. Tell me the answer.
C originate from North Pole and end at its South Pole.
Yes, very good. It's a second. So these will be the type of question from this topic. Not I'm saying that from the whole chapter from this topic because I'm not. We have like let me go just a second. So magnetic field line will be strong where the magnetic field lines are very closely packed. Okay, they are close, very close. So higher, what the magnetic field will be very strong. Clear?
Yes, sir.
I think there is no question. So only these kinds of question will be there from this topic only. Okay, so this is all this in the topic, properties of magnetic field line. Not a very big topic, very small topic. Like I've taken all the terms which can be there because NCERT has very less detailed explanation, but I've expanded it so that you can understand in a better manner. Okay, so let's understand the normal terms. Magnetic field due to different current by current magnetic field. Okay, so this is the topic. So magnetic field will be just a second. So magnetic field due to current carrying conductor, it means that suppose that we have different shapes of conductor. We have to identify which conductor will form which pattern. Okay. Suppose that you have seen this thing. I know like every human body has every human body has the same pattern because we have two legs, we have two eyes, we have two ears, we have two hands, one nose, one mouth. Yes or no? But there are different things, like you've seen this thing, cat species, you've seen this thing, every cat species has different pattern.
Yes, sir.
Yeah, so that's why I'm just a little bit connecting it. So just try to understand this thing. So we have three conductors shape, the general three conductor shape. First one is the straight conductor, the most simplest and most, you can say, most used. Straight conductor means wire,
Like straight.
it's straight conductor, or wire word can also be used, straight wire. Just don't think that it's only to conductor, it can be a wire as well. Okay, a circular loop, okay. Third is solenoid. Solenoid is nothing but solenoid is an extension of circular loop, is an extension of circular loop, so it's nothing but more than that. Okay, so we have three conductors. Okay, we have three conductors, shapes of conductors, which will basically tell you the kinds of pattern they will form. Okay, the first one is the magnetic field due to, so it's current carrying conductor due to straight wire. So I'm writing here a straight wire. Okay, straight wire first. Suppose this thing, this is, suppose mm, this is a wooden block. Okay, wooden block hai. I have basically passed one electric.
So they are not straight, right?
Just a second, just a second. It's not, I'm taking, it's a wooden block. Okay, and in this wooden block, a one electric wire is basically passing.
Yes, sir.
Okay, so basically it's connected like this. I'm trying to form a circuit to explain it to you. The circuit is easy, that's why I'm drawing, but I will take the step of the rest of the circuit because they are a little bit tough to draw. So this is like this. So this is the Battery, because current will be provided by the battery. Okay. Okay, so this is a circuit. Clear, Zainab?
Yes, sir.
So this is positive and this is negative. So current will be going in this direction. Okay. So you can see this thing, straight line is there. So this is the conductor, not this one is the conductor. This is the conductor. Okay. This is the conductor. So basically, when the conductor is there, straight conductor is there, so circular magnetic fields around it will be generated. Suppose this thing, pen hai, this is a pen. Around
Yes.
it, circular magnetic fields, like just a second, let me take one. I have one wire here. Okay. Suppose this is a wire. So what happened is that this is a circle, this is a
Yes, sir.
pen. Okay. So circular wires, this kind of electric field will be generated. Is this visible? Like this?
Yes, sir.
Okay. Concentric, concentric, like it, like small circle, like small circle means high value of magnetic field. Then you have seen when you throw a water pebble into a lake or water, it will form a circular rings around it, and then it will dissolve into the water. But it
Yes,
will
sir.
form a kind of, you can say, waves, circular waves, again and again, bigger radius. Just like same thing will happen like this. If a straight wire is there, this is, and the circular magnetic field will be generated around it. Clear, Zainab?
Yes, sir.
Sure?
Yes, sir.
Okay, very good. Let me write it down. The magnetic field lines around a. How was the maths exam? I think you had maths exam.
Yes, sir. I had it, but
Conductor carrying current concentric circles whose centers lies on the. Okay, so concentric circle means इस टाइप से बनेंगे वो. तो जो सेंटर होगा बेसिकली वो ये वायर जहाँ पे इसको वो कर रही है ना, द प्लेस एट विच दिस वायर बेसिकली intersecting the wooden board. So basically, suppose that point, the place at which it intersections, around that point, circular magnetic field will be generated. Clear?
yes, sir.
Like this. Okay. This is the kind of shape of the. Clear?
Yes, sir.
Okay. So basically, let me write it down as. So basically
So,
the properties of the. Yes, Zainab, you are saying something?
so what is after concentric circle whose?
Concentric means the circles are having same center. You can
No,
see
sir. What
nas
is after that? I couldn't read it.
the concentric circle whose centers lie on the wire.
Yes, sir.
So magnitude. So basically by the experiments, the scientists have seen that the magnitude sorry, the magnitude of the magnitude of magnetic field produced by a straight current conductor conductor at a given point. Is basically two factors are there. First is the magnitude of directly proportional to the current passing in the wire. Okay, in the wire. Second is inversely proportional to the distance of that point. Figure. So basically, so this directly proportional means the more if the value of the magnetic current or like electric current is you can say increased, so the higher magnetic field will be generated around it. Okay, more the value of magnitude of the basically the electric current, the more will be the strength of the magnetic field, right, Zainab?
Yes, sir.
Okay. Next is inversely proportional means if you increase, suppose that thing, this is the magnetic field line. When you increase the distance, the more you will go away from that point, the more the basically the magnitude of the magnetic field will be decreased. So maximum magnetic field, the value basically the maximum magnetic field you will experienced will be much closer at the
Much
center.
more.
Clear?
Yes, sir.
When you go far from the center, the magnetic field will be decreased. Okay, so these are the things which is basically there in like in the first, you can say, carrying conductor, straight one. Clear, Zainab? Please let
Yes,
me
sir.
know, dear, if you have any doubt.
No, sir, I don't have any doubt.
Sure.
Yes, sir.
Okay, so this is the first current carrying conductor, and the two remaining conductor will be doing in the next classes, because I think only 2 or 3 minutes is left, so it won't be possible to complete that topic. So that's why.
Mm.
Okay, so it's clear? Sure.
Yes, sir, it's clear.
Okay, so basically this is the current carrying conductor. And one more thing, Zanam, I would like to ask: magnetic field. Magnetic field is basically a scalar quantity or a vector quantity? Can you tell me?
Vector quantity.
Yes, it's a vector quantity. Basically, it has both magnitude and direction. Clear? Both the things it has.
Yes, sir, because in scalar only direction is there, right?
No, magnitude is there. Direction is not there in scalar quantity. If you add the direction to the scalar quantity, it will become vector quantity.
Yes.
Okay. So these are the things which is
So,
there.
for
Yes,
magnetic field, any specific units are there, like
magnetic field, Tesla.